It's not every day that you have the covers off on a machine and you're able to see what I'm looking at right now. So I wanted to take you guys on this little journey right here. Like, check this out. Now, when you look at most CNC machines, the tables are riding on ball screws. When the spindle comes down, there is a ball screw, and as the screw rotates, it's pulling the spindle down. It's moving the table back and forth and around. And when you look at ball screws, there can be error in the ball screw. The screw over time can get damaged. You can have backlash. There's a lot of different things that can happen that can mess with the precision of the machine. When you look at this, now check this out. This is a linear motor. So if we actually like lift up the camera and we look right in that corner over there, you can actually see light underneath. So right here, this is actually the linear motor. This is the magnet. The motor hovers over the magnet, and then the entire motor has about 2 millimeters of air across everything. So there's nothing that touches. Can you guys actually see that gap right there? It is not touching. It's just hovering right over this magnet. And that's absolutely incredible. Now, what's cool about it is that no mechanical parts are actually touching each other. So you got 2 millimeters between it, and it just slides. So back in the day in Japan, we started seeing linear motors and the technology coming up with high-speed rails. So these trains, they were just running at incredible speeds. The pickup, the slowdown, everything was incredibly fast, and they were running on linear motors. But nobody in machining was using linear motors at that time. So you had some prototypes and people were testing it out. But as far as production and mass volumes, nobody was doing it until Sodic developed their own linear motor in 1998. Now, if the technology was so great, why wouldn't other companies be doing it already? Well, the truth is, it's expensive. So a lot of people were like, well, in this special case, we'll put linear motors on for this special part of this special application. But Sodic came in, and Sodic said, we want to have the most precise mills, the most precise EDMs. We want the quality, the speed, the accuracy, all of it to be on another level. So they independently developed their own linear motors, and they started putting them on their EDMs and high-speed milling machines starting way back in 1998. Now you know the rest of the story, but it's cool, right? Now, if there's so much speed and there's so much accuracy involved, how do you actually keep it from heating up? Well, check this out. So what they did is they actually created their own technology around cooling the linear motor. So when you actually look at the armature on the top of the linear motor right over here, you actually see 2 hoses that are actually going in. You have the clear hose and then the opaque hose. The clear hose is actually coolant going in that is coming out of a chiller that's making it cold and keeping it cold. And it's basically a special system that Sodic came up with. And it's basically pumping it right through the linear motor, keeping everything chilled, keeping everything precise. There's no movement with the table. There's nothing. Like, it is flawless. And right now we're looking at like X-axis. So you got kind of a bridge style up here. So you have like the X moving back and forth above the table. And what it's moving on is linear guides, crazy precise, high level linear guides right here. And then you have linear scales. So then the scale right there that keeps all the measurement absolutely perfect. Everything is like perfectly in tune. And that's why when you look at the system, it doesn't look overly complicated, but when you put it all together on each axis and everything is working perfectly at incredible speeds, you literally have the most accurate machine on the planet. And that could be high-speed machining, that could be EDM, whether it's sinker or wire. Sodic has figured it out. They're not messing around on the low end. They took everything to the highest end. By the way, the machine just got here. The truck pulled up. We took it off the truck. We took it out of all the packaging. We got it locked down. We got the electrical on. That all happened in the last couple days. And then I just started talking to the Sodic guys, and we took off the cover. And I was planning on filming later, and I was like, you know what? I'm just gonna jump in right now and show them what actually matters, because you don't always get to see how everything works. Crazy, right? Now, UX650L. This is the machine right here. And the machine is incredible. You're basically looking from the inside to the outside, and everything is absolutely precise. Everything is perfect. It's absolutely beautiful. Now, if you look at Sodic, and they're known for EDM and top level EDM, and they got the wire and the sinker, why would they have a high speed, highly accurate machine? It's because of the electrodes needed for the sinker. So when you look at mold making and you look at a sinker EDM that actually takes a piece of material and pushes it right through the metal, you're pushing an electrode through that metal. Now the electrode is a machine part, and that's the male part. So when the electrode actually goes into the material and comes out, it leaves a cavity, and the cavity is the exact representation of what the electrode is. Now, when you make an electrode, if you have any chatter, if you have a tiny line, forever, it'll be imprinted every single time you use that sinker to push that electrode. So every piece will be flawed. So we need electrodes to be absolutely perfect, and therefore you get a crazy high-level machine that runs with linear motors and linear guides and has a 40,000, 60,000 RPM spindle, and it can cut glass, it can cut anything flawlessly. It's crazy. I know, I get excited and I get off course too, but anyway, let's get back over here. We set up some indicators in here. So we got 3 indicators. So we got X-axis, Y-axis, and Z-axis. And now we're dealing with microns, so incredibly accurate. We're gonna actually bring the spindle down. We're gonna touch those. But before we get to it, I just wanna step back and look at how beautiful this is, right? Look at the workmanship in the machine. They even make their own controls, and they're incredibly user-friendly. If you actually just look at it, it's like an absolute work of art right here. When you look at the castings, everything Sodic does, everything that matters, they actually don't source. They do it themselves. Everything is internal, so they can test all of it. Everything gets put together. It's their product, and it's on the highest level. It's crazy. The technology, the manufacturing, the workmanship, all of it. I just want to put a shout out to Sodic Japan, Sodic US, Sodic Global, all of you guys. You guys do a phenomenal job. You make an incredible machine. You look at the details, and details matter, so I love it. Now, you know what else matters? Accuracy. So let's check this out. If you actually look at it, now look at each indicator. Again, dealing with microns now. Now I'm gonna hit cycle start over here. Now listen to it. You hear it? No, you don't hear it, because it's so smooth. Now watch it. Now you say you gotta feel the machine. People say on manual machines, they're you have to feel the cut, you can feel. And I always tell them it's funny because when I actually move a CNC machine, I can touch a CNC, I can touch it. I can be across the floor and I can hear it. Right now, it's actually moving. I cannot feel it. You literally can't feel it. It is so smooth, you can't hear it. Can you guys hear it? My mic would be catching it right now. Crazy. So we're moving it, we're moving everything. And what we're gonna do is we're gonna actually come back, and we're just gonna come right into all of those indicators. Drop in, drop in, drop in. Ooh, look at that. That is crazy. You guys just saw it right there. There's no tricks, nothing. But it literally just came down, it hit everything. Absolutely perfect. Everything is absolutely dialed. Now, what the craziest thing here is this test, they actually did on a 20-year-old machine, and it did the exact same thing. It was perfect to the micron. Absolutely perfect. Now, again, to understand it, you have to think about the technology and the linear motors and how nothing is touching, and therefore it needs no maintenance. It's just absolutely perfect. Now, if you want to learn more about Sodic, you want to learn more about these machines, if you are looking for CNC machines in general and you want to actually purchase from us, everything that you purchase from us is helping us fund free education. We're scaling education, and you're helping us do it. So let's lift up education. Let's bring awareness, make tutorials for our kids, for the workforce, everyone, and just pull manufacturing forward into the future. Thank you guys so much. Sodic in the house. We're gonna be actually running our electrodes here. Then we're gonna be syncing our electrodes, and it's all in one cell. It's all automated, it's perfect, and we're teaching you guys exactly how to do it. Boom, baby. Love you guys.